To video 4. In this video, we're going to be covering inheritance, a continuation of inheritance. We'll be focusing on final keywords in Java, abstract classes, and dynamic method binding. So, if we just have a brief look at final keywords in Java, there's three main areas that we're focusing on when we're referring to final keywords in Java. You've got final variables. Now, final variables have to be initialized, and we create constant variables in this case. So when somebody tries to overwrite these variables, it will cause an error. Okay, so if we just have a look here in NetBeans, we've got on line number 14 in our test class, private final, so that's our final keyword, int max line age equals 28. So as you can see, our reference or our instance variable name is actually in capitals, and that is so the coder knows that this variable shouldn't change, and if somebody tries to change it within the code at a later point, it's going to be and cause an error. Also, we generally initialize a constant immediately, although you could always initialize it later if it's in the main method, but once it is initialized, it is a fixed value. Okay, so that's a final for our instance variable or final variable. Final methods. Final methods cannot be overridden but hidden. So if, for example, we were going to inherit from a class and we were going to have a method with the same name, this method cannot essentially override the method in the parent class. So what we'd have to do is make both methods final. And what would happen is essentially we would hide the initial method, and that would allow us to use a new method. So we use final methods if we want to fix a method so somebody cannot change its implementation. Therefore, final methods cannot be overridden but hidden, resulting in, a subclass method being called. So let's just have a look at this. So here we go. We've got public final void shout. Now, obviously, if we think of the term shouting, shouting is always loud. Okay, so it says here system out print line, a shout is always loud. So this is a constant. You don't want that item to change. In your mind, even, we have methods that are constants that we wouldn't particularly want to change. So we use a final method, and you can see final is in the method header, to fix a specific method. Now, because this is a final class, which we're going to discuss in a minute, you can't actually inherit, so we can't extend this class. But if it wasn't a final class and I was to try to override this method in a lower class, it will cause an error. And the only way I would essentially be able to have a method in this subclass with the same name is if I was to also make that a final method. Okay, so let's just go back. And we've got final classes. Final classes are useful for classes such as the string class. They use the term immutable, which means non-changing, in which you want the class to remain fixed and no class to be able to inherit it also. Okay, so here we go. We've got the final word in our class header, which means that you can no longer extend this class. So if I was to try and make a subclass to extend this class, it would cause an error. And I can demonstrate that quickly. So if I just right click here, new Java class, and I'm just going to call it test baby. Apologies for my type. Yep, test baby. And I'm going to try to extend tests. And as you can see, I get an error. So therefore, with a final class, you cannot inherit. Okay. And let's just exit you. So that is final keywords in Java. Moving on next to the abstract class. Apologies if this is a long video, but I'm trying to get through 3 topics. So abstract classes are an excellent item, and this is the next chapter we're moving on to. It's another area of inheritance. So if we declare a class to be abstract, each of its methods can be abstract or not. If you declare a method to be abstract, you must also declare its class to be abstract. So firstly, what is the whole purpose of an abstract class? The purpose of an abstract class is a class that we cannot instantiate from. So if we consider, for example, an animal or an employee. So in the case of an animal, essentially an animal is going to have a subtype. So an animal may be a dog, an animal may be an elephant, but you're not essentially going to have an animal object of its own. It's going to be specific to a specific type of animal. So therefore, you would never really instantiate an animal object on its own because it's going to be a type of animal. So if you instantiate it, what type of animal will that be? Will it be a dog? Will it be a monkey? In the case of an employee, for example, each employee would be more specific, e.g. an employee would be a salaried employee, an hourly employee, or a contract employee, but we may never actually have the need or desire to make an employee object. So let's just have a look at this. So we're just going to jump into NetBeans. We're going to make a new class here. Let's call that animal. So we're using animal before, we've done that before. So I'm going to say animal, let's say 3 for example, because I probably have several animal classes. And I prepared the code earlier, so I'm just going to jump to my code. And I'm going to copy and paste this. I will have to edit some things here. And let's just paste you here. Alright, so I've got my public class animal. I've called it animal3, so I'm just going to edit that. And public class animal3. I have some items, let me just check to make sure everything's okay. Alright, so I'm going to remove the abstract title, I don't know why that's there. Private string name is fine, excellent. Private string get name, okay, and I've got my method here, yep. I'm just going to end that class like so. That method, sorry. Then I've got my public void set name. You can get this code from the book also. It looks like some of my braces have disappeared. I'll just add another brace in here. So let's just check this. Public void set name string animal name equals name. We have an error there. We'll just solve that in a second, no issue. And finally, I'm just going to remove you. Okay, I can see the error. I have no opening curly brace. Alright, so I've got public class animal3. Private string name is my instance variable. I don't know why my class name animal3 is not abstract and does not override abstract methods. Okay, yes, obviously. Now this is an abstract class, so in the heading I need to insert abstract. So public abstract class animal3, and this is one of the key differences. Previously we've not used the word abstract in our title. Now abstract kind of refers to a term of something that is not very clear. Okay, so if we look at this speak method down at the bottom here, you will see that it's essentially not very clear. We have our getName method, which has been defined, and we're familiar with that syntax. It's got return name statement here. Then we've got our public void set name method that takes one parameter, and that's the animal name, and it gives it to the instance variable name. And then we've got our speak method. Now our speak method is an abstract method. As you can see, we have abstract in the title. What's different about this? We have no curly braces here. Why? Because we will not provide the implementation in this class. We will provide it in a class that extends this class, okay, or implements essentially the method. So we simply put our brackets and a semicolon here, which means that we're going to later define that item. Now if we just jump back to our code, you will see that we're going to add a dog class as we have done previously. And we're going to come over here to our animal3, right click, new Java class. We're going to call you the dog class, okay. And we're going to just copy and paste all of that information in here. and it says public dog extends animal. That has to be animal 3. Alright, and again we use the override notation to tell us that we are essentially overriding a method from the superclass. So as you can see, public void speak, each animal is going to speak in its own way. Okay, so we don't actually define the speaking method within the animal class. That's why it's abstract. So it's kind of not very clear, if you understand. So we move to the dog class here, and we define the dog as having a wolf when it speaks. So now we have the implementation between the curly braces, and each subsequent subclass will also define its own speak method. So if I just right click on our gold source package here, I can continue to define subclasses. So our next subclass will be a cow. A cow moves. So we're going to call you cow, and we'll just jump in there. So public class cow extends animal 3. Yep, perfect. And our override notation, again, because we're overriding the speak method, public void speak, system out print moo. And I'm just gonna probably end this video by adding a demo class just to show us how these different methods work. And we will do a little bit more after. So demo class, I'm gonna put my main method here, PSVM tab. And now I'm going to create 2 objects. So I'm going to create a cow object and a dog object. Cow did come first. So dog, and we'll just say dog A equals new dog. Okay, semicolon. Cow B equals new cow. Okay, open bracket, close bracket, semicolon. And we're just going to call those methods. So it's going to be A, and we'll put it in a system out print, A dot speak. Oh, it's void, so we can't actually put it into, it will print automatically, so we can get rid of that. So A dot speak, semicolon, and B dot speak. Okay, A obviously refers to our dog, and B refers to our cow. Can you guess what it's going to print? Let's run that code. It says no main class found, no issue. I just need to refactor so it can find the main method again. Hey, refactor, yep. And let's run that again. Okay, yay. Okay, woof and moo. Okay, and if I wanted to, I could add some further information before it by saying SOUT, a dog makes this sound. Okay, and then just copy and paste. A cow makes this sound. And I'll just run those again. So the dog makes this sound. Woof. A cow makes this sound. Moo. Hey. Why not? Let's just finish it off. So let's just jump back to our presentation. Dynamic method binding. When you create a subclass and one or more subclasses, each object of each subclass is a superclass object. We discussed that previously. When a superclass is abstract, you cannot instantiate objects of the superclass. Again, that's a key element to remember. You can directly create a reference to a superclass abstract object, and each reference chooses the correct speak method based upon the type of animal referenced. So what I'm referring to, if we have a look at that item in the corner, and we can demo this in class, so that's fine. If we have a look at this item in the corner, we have animal Okay, so a cow is an animal, so we can put that on the far left-hand side, and we have a reference for that animal, which is animal reference, and we say animal reference equals new cow. Now, the idea of dynamic binding is simply saying that at the point of running that method, which is speak here, okay, the way that the program or the system is able to select the correct method, as we saw previously, is what we call dynamic binding. So the way that Java is able to select the appropriate method according to the object type, so here we have a new cow, here we have a new dog, is and make sure that we have the correct speak method is called dynamic binding. So although here we've used animal reference twice, okay, we've essentially overwritten the animal reference. But the system knows that animal reference, the first calling here .speak is referring to the cow because that is a cow object originally. Then when we rewrite animal reference as a new dog, okay, now the speak method is referring to a dog. So we can actually demo that. So I'm just going to demo that quickly here, and I'm going to say animal. Yeah, I'm manually typing now. So animal reference equals new dog. Okay, open brackets, close, semicolon, and we simply say, okay, it's animal 3, and we simply say animal reference dot speak, and we just copy and paste. Hey, I love to copy and paste. And again, animal 3, so we can just remove that because we defined it already, and now we're saying cow. So what we are doing, I'll just explain briefly. The first line, we instantiate an object, okay, animal 3, okay, of type animal 3, and we say animal reference equals new dog. Then we say speak. So at this point we expect a woof sound. And then we simply make a new object, which is cow, and we say animal reference you now equal cow. And then when we ask animal reference, that same reference variable, to speak again, it's going to now change what it's thinking. So let's just run that. What do we expect to happen? So we've got a dog makes this sound, woof. A cow makes this sound, moo. And then we've got woof and moo. Okay, so if I just put a line in here just to break everything up. Okay, \n. Okay. So a dog makes this sound woof, a cow makes this sound moo. Woof and moo. And that's dynamic binding. The fact that the Java knows, or the mechanism in which it knows to call the correct method according to the type of object is dynamic binding. I hope you enjoyed that. If you got stuck, rewind and play. Thank you. Sorry about the length. Bye bye.